Hey, welcome back. In this example scene, we're going to go ahead and use rigid bodies, and we're going to create a dynamic simulation using rigid bodies, both active and passive rigid bodies, in an actual production scene to see how it works in an actual sense when you put it to work in the real world. We're going to see how to optimize it, how to solve simulation errors that can occur, like objects penetrating through other objects and going through them when they're not supposed to. Alright, so that's what we're going to be doing in this video. So let's go ahead and get started. Hit Control O to open up an example scene here. And with the project directory that came with this tutorial, you should find a scene called Blender underscore start. So let's go ahead and let's open up that scene. And as you can see, it's probably what you expected. It's a scene of a Blender. Okay, and if we switch from shaded mode to wireframe, we can see inside this Blender we have these sort of blades that rotate here, and then we have this little sphere inside the blender. So the idea here is to create a scene with several spheres kind of just bouncing around and interacting with this blade down here. If I hit play on the keyboard, you'll notice that the blades down there at the bottom, at the base of the blender, are actually spinning and continue to spin forever and ever and ever. Okay, so those are animated. And what we want is for these little spheres to kind of fall down and hit that blade while it's spinning that fast and just interact with it in a realistic way. So that's what we're going to be doing in this scene. So let's go ahead and let's get to it because we have quite a setup to go here. Alright, so I'll hit home on the keyboard to stop the animation and go back to the first frame. Let's start to set up all the rigid bodies that we need to get this simulation here to work. So the first thing I'll do is with the sphere selected, I'm going to turn that one into a rigid body. I'll switch to the simulate menu by hitting 4 on the keyboard, or you can come up to this menu and select it from the sub menu up here. Once we're in the simulate menu with the sphere selected, we'll go into the create menu, we'll go to rigid body, and we'll create an active rigid body because we want this rigid body to be affected by gravity and whatnot. Okay, so once I do that, I'll go ahead and close that PPG. So now I have myself an active rigid body, and if I hit play, nothing's going to happen. We get the same result as we did when we first started. If I hit F to frame in on this sphere, you'll notice that it has a yellow bounding box around it of a cube. This is incorrect. We need this sphere to have a round bounding box or some kind of round collision shape because obviously a cube is not going to work out too well. So with this object selected, I'll go down to the modify menu, click on rigid body, and I'll click on edit rigid body. Once I do that, I can go ahead and scroll down to the rigid body properties right here. And I'll have to switch from a collision type of bounding box to a collision type of bounding sphere. And that'll work just perfect in this case. Fortunately, this little object here is in the shape of a sphere. So it'll work with the bounding sphere perfectly. Okay, now that we got that set up, let's go ahead and let's set up the rigid body for the actual glass here for the blender. Okay, so let's go ahead and do that. We'll select the blender, and then we'll come over here to create rigid body, and we'll create this into a passive rigid body. So once we do that, we can see that the bounding shape is a cube. This obviously is not going to work well because it's not going to take the shape into account of the glass. The problem we have here with this scene is that the glass is a very complex shape. There's an actual inside part to the glass. There's walls to the glass, so this object cannot go through it. But it should be able to freely fall inside this object. So what we'll have to do is come down to its rigid body properties and switch from a bounding box to the actual shape. We won't be able to get away with using convex hull or obviously using any of these bounding shapes. So let's use the actual shape. Okay. Now, because we're using a subdivision surface over here, and we can actually confirm that if I go ahead and I hit the minus key on the number pad of the keyboard, you can start to see how every time I hit the minus key, this object becomes lower res and lower res. If I switch from wireframe to shaded mode, you can see it's more apparent. Here's the low res version of the object. I'll hit the plus key on the keyboard to go ahead and subdivide it a few times. And you notice that it becomes very smooth. That's because it's a subdivision surface. Okay, so what I need to do is I need to switch the subdivision level from 0, which would be this level here, which is 2 blocking 2 square, to maybe something like subdivision level 1 or 2. So let's try subdivision level 1. And then right here for detail, let's switch from low to medium because we're going to need a little bit more detail in the collision calculation here for this glass object. Let's switch back from shaded to a wireframe mode here so we can see. Okay, so now we did that. Let's go ahead and let's close this PPG. Alright, so this object is now a passive rigid body. Right here we have ourselves our active rigid body. Well, since the sphere is going to go ahead and hit this object down here, we have to turn this into a passive rigid body as well. So with this object selected, let's go ahead and let's go to the Create menu. We'll go to Rigid Body and create a passive rigid body out of the blades at the bottom of the blender. Obviously, bounding box isn't going to work, so we'll have to change that. Under the rigid body properties, what we want to do is switch from bounding box to actual shape again. Now, because this object is a very low-res object, we don't need to increase the subdivision level. But, just to get this to look good, let's switch the detail level from low to medium. And now let's go ahead and let's close that. Okay, so now we have ourselves another rigid body right there. Alright, so we're well on our way here. Alright, now the next thing we need to do to turn into a rigid body is the cover up here, the top cover for the blender. That way these spheres, when they start bouncing around, don't fly outside of the blender. Kind of like in real life, you would put the cover on to make sure that the contents don't fly out everywhere. So with that object selected, glass cover, I'll go back to the Create menu, go to Rigid Body, and create that into a passive rigid body. It's not going to move, it's just going to sit there in the top and stop objects from flying out. Now, because this object is on the top, we don't need a lot of detail on it, as you can see, because the objects are just going to make contact with the bottom part of it and not the top. So I'm going to go ahead and leave it with a bounding box shape for the collision type. We don't need to use actual shape and slow down the simulation. We can use bounding box to speed it up. And the bounding box will do an excellent job of creating the collision that we need up there with that lid. So I'll close that. There we go. Okay. The next thing that we need to do is we need to add some forces here to make stuff happen. Because right now, if I go ahead and I hit play, and here we go, exercise making it's building the collision data, it's simulating, it's calculating all the collisions that we need here to make this work. And it just takes a moment, it doesn't take too long, to be honest with you. If you like though, I will go ahead and I'll skip ahead the video so you don't have to watch this. Okay, so I finished calculating, and there's the animation, the blade spinning down the bottom. Now, nothing's happening with the sphere because there's no gravity, there's no forces, there's nothing going on. So the sphere is kind of just sitting there in space, not moving or anything. So I'll hit home to go back to the first frame of the animation. And what we'll have to do is we'll have to add a force. Okay, so I'll go up here to the Get menu, I'll go to Force, and I'll grab myself a turbulence force. Alright, so here's my turbulence. What I want to do is I want to move this turbulence. I probably want to get it right here inside of this glass here. No, actually, edit that out of the video. Edit that out of the video. Starting again in 3, 2, 1. Okay, so here's our turbulence, and you can see it back here. And it's represented by this icon here that has kind of like these spring type shapes and then this arrow. Okay, let's take this object and let's rotate it so the arrow is pointing up like so. And let's come over here and let's change the amplitude to 0.5. There we go. Alright, now let's go ahead and let's hit play and see what happens. Now you can see that there's something going on. The turbulence field is actually affecting the sphere inside. It's causing this kind of turbulence effect, like it gets hit by a wind gust from one side and then another, and so on and so forth. So let's go back to the first frame of the animation. Let's close the turbulence field over here, the PPG. Let's select the sphere that's in the center here. Now let's go ahead and let's go to the Modify menu, Rigid Body, and go to Edit Rigid Body to open up its parameters. What we want to do is go to the Dynamics Initial State parameter set here and switch over to the Velocity tab. We want to give it an initial push. And what we'll do is we'll give it an initial push, and the push will be in the y-axis right here. So in linear velocity for y, we're going to go ahead and put in -25, so it gets pushed down. So it's going to kind of have this this burst of energy that's going to push it down at the beginning of the simulation into those blades right there. And then when it hits them, it's going to react with the turbulence field that we created. So let's hit play. And there it goes. It hit the blades in the bottom, and then it bounced around, and it's hitting the inside walls of the glass, as you can see. So it's not allowed to leave the glass or anything like that. So I'll hit home. Let's make things more interesting by adding more spheres. So we'll create plenty of more spheres in this scene. Let me go over here to the camera options up here. I'll click on the word camera, which is actually a button, and I'll switch to the top view, which will make things easier for us. So here's the glass part of the blender right here. What I'm going to do is, with this sphere selected, I'm going to come up here to the edit menu. I'm going to go to duplicate / instantiate, and what I want to use is the clone single tool. So I'll hit the clone single tool once, and then if I use the move tool, you'll notice that a clone of the object was created. Creating clones is great in XSI because when you create a clone of an active rigid body, it inherits all the parameters of the original rigid body. But clones are a little bit more optimized than using just duplicates. With clones, you get to reuse the same simulation properties of the first one, and it just is a little bit more optimized and works a lot better, especially when you're working with tons and tons of the same object. So with this object still selected, what I'll do is I'll hit the period key on the keyboard to repeat the last command, which was to clone. So I'll continue to clone this object by hitting the period key over and over again. So there we go. Maybe I'll place a couple in the center right here. Okay, perfect. I'll come over here and switch back to my camera view, like so. Now we have ourselves plenty of spheres inside of this object here. So now what I'll do is I'll hit play, and now we have lots of spheres jumping around in our scene here. Now you might notice some strange issues. You might notice that some of the spheres might go through the walls of the glass. Some of them might not react properly with the blades that are spinning down here. So what we need to do is increase the accuracy of the simulation to get a more realistic result. So to do that is actually pretty easy. We'll hit 8 on the keyboard to open up the Explorer. We'll switch to the scope from Scene Root by clicking on the Scene Root button to Environments, like we've done before in the past. Okay, so here we'll expand the operators folder down here, and you'll see PhysX Dynamics Operator. And what we'll do is we'll just go ahead and click on the little icon there to open up the Dynamics Operator property page. This one allows us to control the simulation accuracy and the speed of the simulation with the substeps parameter here. Okay, so we're going to use the substeps to control the accuracy of the simulation. So let's begin to increase these substeps. I'm going to go ahead and double them to a value of 8. Now I'll hit play again. And you can see the simulation is a little bit better. I don't like how that sphere down there is reacting with the blades right there, although it does look pretty realistic. Let's try increasing the substeps a little bit more, to say something like maybe 10. And let's turn on adaptive substepping. And we'll leave the subdivision depth at 8. And we'll hit play. And you can see one of the spheres was knocked right out of the glass. That is an inaccuracy with the simulation. So what we need to do is we need to start to increase the accuracy of the simulation here by increasing the substeps. So I'll increase the substeps to 15, and I'll hit home, and I'll hit play again. And the same thing happened. I don't know if you noticed, but one of the spheres, if I go slowly frame by frame, and let me close this Explorer, actually flew out of the glass there. So let's increase the substeps to 20. Hit home and hit play again. And now we can see that none of the spheres flew out of the glass. Let's try that again. We can see now that the simulation is a lot more accurate, and the system is taking the collisions into account with a lot more accuracy, which stops that abnormal behavior of occurring where the spheres would fly right through the glass. So let me increase the substeps to 25 just to get a very good result here. I'll hit play, and there we go. Now we're getting a more accurate, much better result. Okay, much better. Okay, now what I think I'm going to do is I'm going to go here to the turbulence field, and I'm going to change its amplitude here. I'm going to sort of increase the strength of the amplitude here to make it more powerful. So maybe I'll switch it to a value of 2. Now let's see what happens. Let's hit play. So now we have a little bit more turbulence. The objects are moving around a little bit more. And we can always increase that amplitude more. So maybe we'll double it to 4. Hit home to go back to the first frame of the animation and hit play. And there we go. Now objects are moving around a lot more inside that blender, which is a pretty neat effect. And every time that that they fall down and they end up making contact with the blades right there, they'll react realistically. They'll actually get hit by the blades and they'll fly up or fly sideways, impact other spheres inside the blender there, and so on and so forth. So I'll close that, and there we go. I think we're pretty much done here with this. So you got to see how to actually use dynamics in a real world sense by creating these rigid body spheres inside the glass and having them react to these blades in the bottom and having them react to a field, especially one as interesting as the turbulence force over here. These objects inside are able to react realistically. They can't get out of the glass because the simulation, we increased the substeps, and they're pretty much stuck in there and just will continue to bounce around and smack into each other and react realistically. So I invite you and I encourage you to create your own simulations. Just come up with whatever you can out of your imagination. A blender is just one idea, but as you can probably imagine, there's so many possibilities out there with dynamics inside of XSI. So take advantage of the powerful Aegea Physics dynamics engine. It's extremely powerful, very accurate, and as you can see, very fast for this kind of simulation. Okay, so that's going to do it for this video. Thanks for watching.